Good morning, everyone. Thank you for joining us today in our joint webinar between Silverfort and Palo Alto. So today we're going to talk about how XDR and Silverfort can actually enforce each other. So we have a cool use case that we're going to show you today, which is actually about service accounts. As you may know, if you look at today's attacks, all the adversaries now try to use those service accounts in your network to go for that lateral movement. So it's very important to say that during our demo, we're gonna do a certain exploit, which of course XDR can see, but there are possible, or at least there's a way that you can bypass that. And then we need to make sure that we can see that someone is trying to use those service accounts. So the whole idea is to create visibility inside your network with the combination of a cool XDR tool and then Silverfort for actually seeing all those accounts being used. I'm not alone today, so let me introduce myself. My name is Stan van Hoof. I'm a business development manager at Exclusive Networks, but actually the demo is built by Davey and Steven. So Davey, please introduce yourself.
Hey, good morning, everybody. So yeah, I'm Davey. I'm a technical business consultant at Exclusive Networks. My main focus is on emerging technologies like Silverfort today, and I'm here together with Steven. Steven, word is yours.
Hello, everybody. Yes, my name is Steven. I'm working in the same team as Davey, so the technical team is Exclusive Networks, and I'm also a pre-sales engineer. So I will explain in short Cortex XDR. Okay, so what is the approach of Cortex XDR? So let's take a real-life example where a user opens an email with a Word document attached which contains a malicious macro. This is just an example. So in this case, the user is using an older version of Word which contains a vulnerability. So the Word application will be exploited and the attacker can control the user's workstation. Next, the attacker will then install typically additional malware to get persistent remote access, and then he can move laterally through the network to look for example, confidential data to exfiltrate or to do other malicious things. Now, with Cortex XDR, the victim's PC would have been protected against both malware and also against exploits. Prevention is key here, okay? So what we can prevent, we should always do that, but we have to be realistic and accept the fact that we will not be able to prevent everything. So in case of a breach, it's important that we will detect it as soon as possible and that we can do something about it. Now, let's first talk about the prevention part, endpoint protection. It's two things. The first thing is malware protection, and the second thing is exploit prevention. Now, when we talk about malware, so when an executable or, for example, a macro is opened, Cortex XDR will check in real time with Wildfire, and Wildfire is the threat intelligence cloud of Palo Alto Networks, which you might probably know from the next generation firewall. So we will check against Wildfire to see if the file or the macro has been seen before and if it's benign or malicious. Okay. Now, in case Wildfire has never seen the file before or we are offline, the Cortex XDR agent still has a local analysis engine to detect and stop potential malware locally on the machine. Now, Cortex XDR also protects against ransomware and spinning up of child processes, for example, Internet Explorer opening PowerShell, for example. So that's what we called behavioral threat protection. So this is the malware protection part of Cortex XDR. Now, when we talk about exploit protection or exploit prevention, okay, so legitimate applications such as Word, Adobe Flash, or Chrome, they often have bugs called vulnerabilities. Now, if we don't patch these vulnerabilities, they can be exploited. But in order to exploit an application, an attacker has to use exploit techniques such as heap spray, ROP, DLL injection, and so on. Now, today we know of about 22 or 23 known exploit techniques, and an attacker typically needs to use 3 or 4 of them to successfully exploit an application. Now, what Cortex XDR is doing, it focuses on these exploit techniques rather than focusing on the different exploits individually. So as these techniques are always the same, we can prevent exploit attacks without the need for any signatures. And that is done by using exploit prevention modules. So we have, for example, an EPM for heap spray, and we have other EPMs for example, DLL ingestion. So that was the prevention part. Now let's continue to threat detection and investigation. What we see is that customers often have different point solutions, which on its own can be very decent solutions. But the problem here is that these different solutions all generate really a lot of logs. So in order to make sense out of all these logs, we need to aggregate them and to correlate them in one place. Now we have log solutions such as SIEM, which partially do that, but we will still end up with way too much noise. So it's almost impossible for an analyst to focus on the really important things. Now with Cortex XDR, all logs coming from the endpoint, but also from the next generation firewall or from SASE solutions such as Prisma Access, but also from third-party solutions such as Cisco, Fortinet, Checkpoint. All these logs are centralized in a cloud storage, what we call the Cortex data lake. Now, Cortex XDR will then do its magic using machine learning and AI techniques, and will present the analyst with only the relevant things he should focus on. So here you see how different alerts are grouped into one incident. Not only alerts from the endpoint, but also alerts from sources like in this example, a phishing alert coming from a Palo Alto next generation firewall. Now all Cortex XDR agents are sending rich endpoint data, so we can really see which processes are part of the attack chain, like you see here. Okay, and in this example, this screenshot, you see here on the lower end, the raw alerts arriving at Cortex XDR. Now, the first one here is a prevention alert coming from a user's agent, which has detected a malware. And the second one you see is a BIOC, which stands for Behavioral Indicators of Compromise. So that's detected by Cortex XDR based on logs which were sent to the cloud. And these events can also be shown in a nice graphical view. That's what we call the causality chain view. Here you see, for example, Explorer.exe, which spinned up wscript.exe, which has launched PowerShell. Now, also a very important part of Cortex XDR is analytics. So the analytics engine retrieves logs from the Cortex data lake to understand the normal behavior. So it will create a baseline. So the normal behavior of users and network components, so that it can raise alerts when abnormal activity occurs. So when you deviate from the baseline. For example, a user accessing a server which he normally never does. Okay. And last but not least, it's nice that Cortex XDR can detect all these things, but we must be able to act upon it, of course. So this is done with response actions, like, for example, quarantine the host from the network, or sending alerts to trigger third-party solutions, such as Silverfort, which we will show in the demo. So the goal is then that these third-party solutions can then take further measures themselves. So that's it for me. With that, I would like to give the word to Davy.
So a little word on Silverfort. If we look at current network deployments today, we see a mix of hybrid environments, which is based. So we see hybrid environments, which is basically a mix between on-premise and cloud. We see a lot of customer environments who have a sync between cloud environments and on-premise. But there's one constant in all those environments, and that is user authentication, access management. So people need to authenticate, systems need to authenticate to gain access to certain resources. And that's basically username, password. And some environments, they start enforcing MFA, especially on cloud, because that's easy to do. And also have some access management solution in place. But this is very a siloed, most of the time it's a siloed approach. And this is where Silverfort basically takes a different angle and basically provides a unified identity protection platform, meaning to give full visibility, MFA, and risk-based authentication capabilities to your whole environment, on-premise and cloud. Now, if you look at data breaches and basically analysis of attacks these days, we see that compromised credentials are basically leveraged in all these attacks. It's still used for initial access, spreading across the network, privilege escalation, you name it. And that's a bit of a strange thing, because a lot of companies already implemented MFA on quite some resources, and still that problem exists. That problem is growing. Credentials are stolen, accounts are breached. So it's basically a bit of the question, why is this happening? And one of the reasons is that attacks, of course, evolve. Attackers have the same, even more information that we have. It's a bit of a cat and mouse game. But basically, there are some components that we can identify on what might be the issue here. One of the reasons that we see is that while there are a lot of enterprises and all environments, they use, like we said, identity access management solutions like cloud identity providers to secure the cloud infrastructure. There's on-premise, think about Active Directory, an identity provider to manage usernames, users and passwords, and the access control for the on-premise environment. But also privileged access management solution, and of course the VPN and proxy for entering the corporate network from a remote location. Now, all these solutions, they're great solutions, right? They all provide their own security in terms of resource protection. But the main problem there is that they only see a part of the puzzle, let's say. They only see a part of your resources. They also don't really interact with each other. They all have the visibility on their own part, but they don't really talk to each other and give you a full insight on what is really going on in your environment. Not only that, it's also not always possible to integrate applications with let's say, step-up authentication in terms like MFA or something. There's two aspects there. For the resources that you can protect, the question there is, are you sure that you're protecting all interfaces to that server? Think on a Windows server, having remote desktop capabilities, maybe you're securing that with multi-factor authentication. But what about Remote PowerShell, or what about WMI? We will see in the demo that we actually use WMI to do lateral movement. Do you have anything in place to do an MFA or a step-up authentication on that interface? That is a question that you should really consider when doing this kind of protections. And also, what do you do with legacy applications? What do you do with application that is difficult to integrate with MFA solutions, or for example, to have that legacy application protected? Think about file share, think about databases, IT infrastructure, etc., etc. So these are aspects that are very important. You want the full insights on all the authentication that happen on your network, and not only on the resources that you are able to protect, but you want to see them all, and you also want to be able to protect them all with an advanced step-up multi-factor authentication mechanism. And that's basically where Silverfort really puts the focus on. Silverfort is actually an extension for your identity provider solutions, and it basically looks at your environment and takes in all the authentication that happen in the network. If they're now just normal username password authentication on the cloud, on premise, think about Active Directory integrations. Silverfort can see it all. Silverfort can see who's logging in where. And because we can see that, it's also then easy to analyze, to start analyzing that behavior. What is normal? We have that insights on who is logging in where, and we can check out, okay, what is normal behavior on this environment, just to build a sort of a pattern or a baseline, let's say, on what we expect in terms of account behavior, human account, machine account, to think about service accounts on which we will focus also in our demo. But basically telling there, is this behavior expected? And if we see some activity that is not expected, what will we do with it? So Silverfort provides not only the visibility and what we call the risk analysis based on that behavior of every entity in your environment, but we can also do the adaptive protection mechanism, which is the next step. You have the insights now, we know what's going on, we know what the behavior is of the environment and of all the accounts and machines in the network in terms of authentication, of course. So let's use that to add an additional protective level. Like I said, Silverfort integrates with the identity provider solutions, and we form like a sort of second factor, more like an authentication firewall maybe on those identity providers. So we can basically enforce a policy and say, okay, for this authentication request, we want you to do an additional MFA confirmation. And that can be done using a Silverfort application, or it can be done using a third-party application like Microsoft Authenticator, Okta Duo, you name it. It's more of like a user experience there to make sure that you don't have 20 types of MFA applications in your environment. So that is not really important how we confirm it. It's just important that that protection is present and that we enforce MFA whenever we say that is needed from an administrative point of view, or we say that the risk engine decided that because the behavior is suspicious, we want you to enforce MFA. And of course, all that information is very valuable to export to whatever SIEM or security products that you have. That is also the capability that is available through API, which we will also use in our demo. So briefly on the use cases, so extend MFA to any sensitive asset. It is important to notice that Silverfort does this without any agent or proxy technology in your environment. You don't need any agent on endpoints, on servers, because of that integration with identity provider, with the central point of your authentication handling, let's say. The risk engine provides risk-based authentication and also enforces the zero trust policy in your environment. Don't trust anything in your network. Let the risk engine handle it and make sure that he can see what behavior is suspicious. Human accounts are, let's say, pretty easy to protect. There's a user behind it. You can notify them with an MFA and allow them to do an MFA confirmation. But what you do with service accounts, it's not easy. There's no user behind it, so you cannot MFA on that because there's nobody who can confirm that multi-factor authentication. Silverfort has a different approach to protect the service accounts using service account flow protection, and we will also focus on that, like Stan already mentioned in the beginning. We will focus on it in the demo, so you will see how that works. And finally, of course, support migration to the cloud. It's a mix between on-premise and cloud environment that we see today. And Silverfort has examples of capabilities to use single sign-on to Azure, for example, to protect your on-premise legacy applications. Even if you don't want to do it with MFA, you can still use that bridging to the cloud, and even other cloud integrations are possible. So that is, of course, part of the roadmap and part of the product. In terms of architecture, again, it's a non-intrusive architecture, no agents, no code changes. We can easily integrate MFA on for example, an LDAP authentication configured on, let's say, on a firewall application or something else. That's pretty easy to do. Also, it's protecting the unprotectable. Make sure that you can enforce MFA on applications that are legacy and not always easy to or cannot integrate even with existing solutions. And then, like we said, human accounts, machine-to-machine, service account protection, and that AI-driven risk engine. It's for the last two we will show extensively in the demo that you will see shortly. A little last word on the risk engine itself. It basically is an engine that, like I said, analyzes behavior of your entities. It starts with anomaly detection, like what is the behavior that we expect of a user of a system. It uses machine learning to learn that if things are normal and then if it's, of course, a suspicious activity. We also have patterns that identify the known threats like lateral move and brute force attack. In terms of authentication, the product can take it out and also give that as a feed it to the risk engine and say, this is an input, something is going on with that user. We need to get the risk up. And then finally, the external risk indications is an input from third-party solutions like Palo Alto XDR, for example, is one of the existing integrations. We build our own in the demo. We build our own integration using the Silverfort API, and we will modify the risk engine, or at least input some information in it using our own program. So that is also possible, and that's a bit the purpose of the demo today, to use that mechanism. So that was briefly an introduction to Silverfort. I'm going to show you just briefly on that integrator that we wrote. So this is an integrator we wrote between Silverfort and Cortex XDR. It's developed by ourselves, so it's for demo purposes only. But it's important that you understand for the demo what we exactly created. So we actually had two flows. The first flow is that we look, that our program looks at Cortex XDR and basically asks for all the alerts that happen in our environment. That means if Cortex sees anything, and it's important to notice here that in our demo, Cortex is mainly in detection mode because we don't want it to block anything or prevent anything yet, just for our demo purposes. Just so we let it detect stuff, and if an alert pops up, our integrator will pick it up, will take some additional information or query some additional information from Cortex, and we'll put that information or translate it to a risk update for Silverfort. A risk update on the machines and also on the accounts that are involved in that alert. Next flow, we turn it around. We basically look at Silverfort and we ask for all blocked MFAs that happen. And if we see that a certain threshold has been reached for a certain user in blocked MFAs, we analyze this as something suspicious, and that we basically said, okay, for this user or this host, we want to block and we want to isolate the host from the network. Since the user who's working on it has now already blocked, in our case, 3 MFAs, that's a bit too much for us, something that might not be the user trying to authenticate to a system. So we deduce, okay, we think that this host is compromised, let's kick it off the network. That's basically 2 use cases that we built in our integrator and that we will use today. In terms of architecture, so the integrator talks to the APIs of both products that's HTTPS based, nothing special there. It's the Cortex is running in the cloud, the Silverfort is running in our environment, but can be cloud-based as well. And we also look at the syslog output from Silverfort. So we have a Linux machine which runs a logstash, takes out the syslog from Silverfort, and converts it into a JSON file, which we can then again take into our integrator. We do that to look at the blocked MFAs, so the second flow. The first flow is done purely based on API calls that you see here. And finally, if you're interested, we did it before, now we do it again. We have made the API wrappers available on our GitHub page. Feel free to download it, to fork it, to extend it, whatever you want. It's a cool thing to use in Python. You can basically start using functions to call the APIs. You just input your keys to talk to the API, and then you can start building stuff in Python without having to figure out how the API actually works. It's a bit of a wrapper surrounding that API calls, making it a bit more easy for you to work with it in Python, of course. So that's briefly on how the integrator works, which brings us actually to the real demo. And let's start first with discussing how we built the attack itself. First of all, there are 2 use cases that we will focus on. Now, we will use a method called curb roasting. What this is really do is we're going to focus on a service account. We have an SQL server running in the environment. That SQL server is running within a service account, an SPN, a service principal name, called SVC_SQL server 01. Now, basically what curb roasting does is that we, from whatever machine in the network, if you are domain joined that's sufficient, so a normal user, which we will be in the attack, can request a ticket to the domain controller for that, to talk to that service, to that SQL server. Sorry. So that basically means that what will happen is that the domain controller will return a ticket to talk to that SQL server. That ticket will be signed with an NTLM hash of the password of that service account. And we are interested in that NTLM hash because we can take that offline and crack it. And that's also what we will do. We will crack the password hash and we will basically get the password of that service account, which might help us to move lateral in the network. That's our first use case, and we'll also show how to protect that with Silverfort in terms of service account flow protection. Second thing is that since we will be a bit blocked, we will look at we will try to move to a domain admin and basically try to use another domain admin to gain access to the network. And we will see that Cortex will also give us a high risk alert on that part. And since we will get a high risk alert, our program will decide to increase the risk in Silverfort for all the domain admins in the environment, which also means that that's the idea we had. Okay, like if we see something suspicious on the network, let's just increase the risk for all domain admins, which means that they will have to do MFA when they connect somewhere. It's a mechanism of prevention that we basically alert on and say, okay, let's do this, so we can protect our domain admins with MFA using the Silverfort solution. Now, Stan, if you briefly want to talk about our exploit to get into the network as an attacker.
Okay, thank you, Davey. So what we're gonna do is we're gonna phish our victim. Phishing is still a very popular way to get inside the network. I mean, email is still the #1 attack vector for any breach nowadays. So we're gonna use something that everyone wants to know, is some information about COVID-19. So we're impersonating a domain that we bought during Black Friday, so it was very cheap. And we're gonna send an email, and our user is gonna click on a certain link. Now that link will go to a website, and it hosts a malicious script. And it's gonna use an exploit inside Chrome. Why do we use Chrome? Because Chrome is a very popular browser, and browser today is almost the same as an entire operation system. So that's why when you click on it, it will do certain stuff, and it will escape Chrome, and it will run our malware. From that point, we have command and control traffic. So that means that our attacker has a connection to the victim. And our attacker will do all kinds of stuff. I mean, that's live that we're gonna do this, which is in a reverse shell. So our attacker can give commands to our victim. And that is Davey, who's gonna be the attacker also, and he's gonna try to go lateral in that environment at that point.
Yes, all right, thanks, Stan. Okay, so like Stan said, we're gonna do this live, so I hope everything goes well. We prefer live demos, that's always a bit cooler. And it's not a trick for sure. So let's kick into it. Let's shut down the slides and let me show you some environments. First of all, I need to bring back my phone because my phone is connected from the screen. I'm mirroring my screen for you so that you can see if we get any MFA prompts from Silverfort. So let me just briefly try to bring that up again. Okay, that doesn't work. Just a second. Let me close it down.
In the meanwhile, we use Gmail here in this use case. I mean, a lot of companies have invested a lot of money in good phishing equipment or anti-phishing equipment, but in a lot of cases, people can still access their private email. And let me tell you that Gmail, while they do their best, is really not good enough to protect your environment.
Yeah, indeed. Okay, so that worked again. So basically what we're going to do is we're going to start here at the left top is we're going to start our integrated program. So that's what we written in Python. It's the program, it keeps on running. So it says it's all up and running, and it looks at our environment, and we have two workstations. It's a workstation Pollux and a workstation Altair. We'll do the attack with Pollux, but basically it looks at the environment, and just keep an eye on it. It will show alerts coming from Cortex, and it will show the activity that it does through to Silverfort. What we're also going to do here is, we already started it, is our Metasploit environment running. So we have our Metasploit ready to get in. We're going to start the exploit here. So I will do some copy paste of the commands to make sure that we don't mistype anything. But basically we load the exploit here and then we say exploit. So we use the Chrome exploit. Now it's waiting for us to get into a certain link. If we go to the user now, and like Stan said, we have Gmail here. We got a nice new email to register your Johnson & Johnson vaccine. We click on it, and yeah, we want that vaccine. So basically, here's a link. So we're going to open that in a new tab, and it keeps on loading. So okay, that's weird. But if we look at our Metasploit environment, we basically see an incoming MetaPreter session. So our exploit worked. We have a session available right now. If I'm typing the commands, should work. There we see we have one session which is actually open towards the the user system right now. So we can jump into that session like this. Just a word on the environment, maybe. Again, important to notice that Cortex is running on this system. We can see it here. I'll show you. But Cortex is in detection mode for the exploit mechanism as well. So that this is an old exploit. It's not working on new environments. But for our demo purposes, we did it in a detection mode so that we could use it, of course. So we're an attacker. We have a session on the user system, so we can start exploring a bit, right? Like, who are we? We're called user Ezio. We're in the domain DDM, and our user is Ezio. We can check if maybe we have system access. Apparently we don't. So we cannot gain average. We don't have system rights. So that's a bit of a shame. Can't do a lot with that. We can maybe try opening a shell. That worked. So we're on the system itself in a shell. Let's see what the host name is. So we are on workstation Pollux. So okay. Again, who am I? I'm user Ezio. So my shell is responding well. So that's good. Let's start exploring the domain. Let's see what we can find on the domain level to see what kind of information we can get. Again, I'm a normal user. I don't have any elevated rights. I'm not a local admin or anything. I'm just a user. I'm not a domain admin, but still I can query some information. That is default. You can do this in every environment. So we can see here for this domain who the users are. So we have an ATM that looks like an admin account. We have an Altair, we have Desmond, a lot of users, and we have 2 SVC underscore accounts, of which one is the SQL server. That might be interesting for us since service accounts are always interesting to look into. Let's query the network and see if we get anything more on service accounts. We basically do. This is a build again. Sorry for going a bit too fast. This is a built-in account, built-in command. Sorry, which basically lists the service accounts in the domain. And you got a lot of built-in service accounts, but we are interested in the ones, and in this one, for example, where it shows that it's basically a user-created one. It's in the user's CN, so it could be interesting for us to have an investigation on that part. So like we said, we're going to use curb roasting. So what we do is going to request a ticket for that account and basically look into get the hash of the password and try to crack that password.
I think it's also important to mention that except for the initial exploits, we didn't use any malware at all. This is just built in inside Windows, and it's very difficult to detect this kind of stuff.
Yeah, you also see that there's no alerting yet. Like Stan said, beside the exploit, of course. This is all indeed built-in tools. We're not touching disk with any file that we need to provide. Also, the command that we will run now is a PowerShell command scripting. We're not touching, again, any disk, so there's no malware involved. So I'm running a command now. It's PowerShell invoke Kerberos script from the Powersploit command tools. And basically what you see here is that 2 service account, let's say, tickets have been requested. One for the Silverfort, but the other one is for the server SQL server 01. The output that you see here is actually the hash of the password of that account. So that's just a normal Kerberos request that every user can do this. Yes, this is not malicious activity because you basically can talk to every service in the network. If you don't have access, you don't have access. But look at our integrator. Look what he does. He basically, and I'm going to scroll a bit back. We got a new Cortex alert, right? Cortex said, okay, I've seen some behavior from Pollux. It's a behavior threat, so I'm going to update the risk of host and of the user. The host is Pollux, the user is Ezio. Because the user is active on a host with an alert XDR agent malware. That's Cortex saying that I've seen something under the category malware. It's a behavioral threat. So Cortex throws the alert. We're looking at it. We take it out and we update the risk into Silverfort. Next, what also happens is since we've seen a high risk alert, you can see it here that the risk is high. We're basically updating the risk for all domain admins. Remember that we said in the preparation that we of the explanation of our attack is that we want to make sure that our domain admins are protected. So we insert a critical level risk update to Silverfort for all our domain admins. So they're not even involved right now in the attack. We don't care. There is something going on in the network that we suspect is suspicious. I mean, it's a high risk. So let's just update the risk of all the domain admins. If they need to do 2 times MFA more than they do normally, that's okay. That's not bad. It's better than letting the attacker do his thing. We also see that there's another one alert coming in, same reason. So that happens if Cortex mentioned it, we just pick it up and we do an update of the risks. So Cortex has seen that we did a curb roasting attack, right? Even if that is actually normal behavior, Cortex has noticed that it's going on and we did an update of the risk. Let's just briefly look into Cortex and let's briefly look into Silverfort and see what the result is. Let me refresh this page first. So this is the Cortex interface. It's showing quite some information. Let me go to the alert table, sorry, where we look at everything that is being alerted, and it's on the last 7 days is perfect, so we shouldn't see too much. There we go. So we see here, this is another environment. You should look at we have Pollux here. You can see that these 3 items are basically the detection of the BIOC and then the agent giving that information. So we can dive into it with the causality chain like Steven explained in the beginning of the session. And we'll see that causality chain, if we have, there we go. Then we'll see here that we actually indeed came to Chrome. We moved to a command prompt, we did PowerShell, and if we click on that PowerShell, you will see here that it detected the command that we did, the PowerShell script, to get that curb roast, or do the curb roasting attack, or get that curb roast ticket. So that's good. That's our alert. Let's look at Silverfort. How does Silverfort look? Basically, let's start with our risk. One of the items was the workstation, WS Pollux. And we can see it's a high risk. Look at the indicators. There we go. Cortex XDR, malware threat, behavior threat detected. So we inserted risk for that entity, for that workstation. The other one was a user, Ezio. No, sorry. I need to look at the admins. These were Altair and ADM Davy. So let's look at Altair. Apparently that's we've seen it as a domain admin. 3 risk indicators. It's on a high risk level. So indeed, this is a domain admin, which is the information we take from Silverfort. It has a password that doesn't, the user has a password that does not expire. And again, the Cortex API has received a risk update from our program. We can also look at the insights page in Silverfort and we'll see that same information. So we have our SQL Server service account. We have Altair, who is a high risk. You can also see in our domain admins, indeed, Altair is a domain admin. ADM Davy, which we suspected on the naming convention. But look, we also have this as a domain admin. And if we go in this insights, we also see that this indeed confirms that SVC SQL Server is a service principal name that is actually also an admin. Now, as an attacker, we don't know that, right? We don't know. We want to figure it out. But in Silverfort, we already see it. So that's a good thing, as on the defender part of site, we can see that this information is available. And our program used this information to actually already update and secure these kinds of accounts. So let's move ahead with our attack, right? We have the hash now, so that's interesting. Now, I'm not going to copy paste it because I already did it up front, but we have a Kali running right here, which we can basically use. And I need to go to the folder of our webinar. There we go. There's a tool called Hashcat, and we can use it to crack this hash. We copied the hash in this file, so this is the same hash from the output. You can just copy paste this. Basically, that's basically taking out the information from the environment you are attacking and putting it in our own environment. So this Kali is just running locally, right? What we're going to do is we're going to crack this. There's one line for this in my history. Voila, there we go. It uses a word list, so it's a dictionary attack, and we're going to try to crack this hash. We basically allow it to run. It's running. It's a pretty simple password, else we would be here for a few days. You can also use GPU power to do this. Now it's a simple password. Oh, sorry for that. And basically what Hashcat says is, I cracked this hash, and this is the password. Test1234 $. So we just found the password for the SVC SQL Server 01 account. Now that's interesting, because now we can go back to the environment and we can basically start or try starting moving lateral in the environment itself. So we're still here on our shell. We're still on our host. So let's move ahead. Now, before we do that, one thing I wanted to show you is how are we gonna try to protect this? Because we have now the password of a service account in the environment. So how can we make sure that an attacker cannot move or cannot use it to go lateral? This is where the service account table or service account protection of Silverfort comes in. So Silverfort basically builds automatically a table of service accounts in your environment. We only have one, so it saw it. This is the one that we have. It automatically detects what sources and destinations this is using. So we're using a source. It's seen it being used in these sources, and it's seen it being used towards the destinations. And what we can do in Silverfort to say, okay, you know what? I know, or I analyzed on basis of the logs, that this service account is only used from the server Mars. Mars is a server that is running the SQL server. One day an SQL server will be running on Mars. We are a bit ahead of our time. Now we can protect this. It's not active yet because first we want to show you that we can actually move lateral with it. And then we're going to enable this, and then we'll do it again. All right. So let's go back to our MeterBreather session here. And let's just do something simple. Let's just deploy a calculator .exe on our server Mars using that account. So what I'm doing is I'm using WMI. I'm connecting to server Mars. I'm using this account, the one that we cracked. I'm filling in the password that we cracked, and I'm calling a process calculator.exe. I'm running this, and it says executed successful. Well, let's confirm. We're here on server Mars. We have a process explorer running here, and if everything goes well, we should see a calculator that's with the C. Should be somewhere over here. Stan, help me out if you see it, because I don't see it. Let me just look down. There it is. It's Win32 calculator. Sorry. So it just spawned a calculator with that service account on the other machine. You don't see it, right? So this is great stuff to inject malware, to put stuff into that on that server and inject the malware in it. Now, we should not allow this. This should not be possible since the service account is not meant to be used from that location. So let's activate the protection in Silverfort. We're basically saying, look, I'm going to enable this policy, which is automatically built by Silverfort. I'm selecting a few of these items because I know that it's only used from Mars, and we have a block access. If this flow doesn't match, we do a block access. So basically saying that this service account can only be used from the Mars server. Now let's go back and let's just try to do this again. Right? Let's try again to spawn a calculator on the server. Right? Let's do that again. Now the access is denied. Right? Is it Silverfort that does the block? It is Silverfort. Let me show you in the logs. It was already there. There you go. You can see that I'm trying to use this account from Pollux. That's the machine that we have our MeterBreather session on that is actually compromised towards server Mars, and we got a deny to use that account. So very simple, but very effective protection. So as an attacker, we're a bit stuck, right? We don't have anything else to do with that service account. We cannot go anywhere. We keep on getting blocked. So let's try something else, right? We have a password now of that service account. Let's see who's admin in the domain. Again, building commands, nothing, no exploit, nothing special. We just do a net group domain admin / domain, and we see other domain admins. This, yeah, we expected, but Altair is apparently also a domain admin. So one thing we can do is, or that we will try to do, is we'll go in PowerShell. Okay, that worked. And we'll see if we maybe can log in using that service account to log in on a domain controller, because it's hard to protect it towards the domain controller. And let's see if we can reset the password of Altair, right? I need to create some variables first. It's basically just creating a user and a password variable and create a credential object into PowerShell to allow me to log in. And let me see if I can invoke just a command towards the DC. It's just calling the host name, and it uses my credential. And again, the credential object I created here is using that SQL server account. Let's see. Okay, that worked. I print out the host name DC01. So that's interesting. So now let me try to see if I can reset the password of that user Altair. What I do is I run the same command, but I don't call the host name. I run a script here, basically doing a set AD account password for Altair. In the domain, I want to reset the password to test1234. So I don't know what the password of Altair is. I don't really care. I have access with SQL Server 01, so I might be able to do that. That gives no error, so that looks fine. So let me try. I'm creating a new object for the user Altair, and I use a new user. I use a new password called test1234, which I set in the reset. I create new credential object in my PowerShell, and I'm going to do exactly the same as before, saying I'm going to call the host name on this time server Mars. But now I use my second credential object, that is the credential object of Altair with the password that I just set. So see if that works. And that works. I get the server Mars information. Now, normally, we don't want this to allow. So let me just see if I can bring back my phone back. There we go. So let's see what Silverfort shows here. So we have server Mars. All right, that's good. So what we basically want to do, and now I need to check, my integrator should see something is going on here. Let me try again. I should get a block. Let me just quickly look at my policies for that, sorry. Higher above, let's look at our investigation for Altair. The high risk. So let me try that once more. Okay, not sure what's going on here, but this one should be blocked finally because my admin account should have a multi-factor authentication. Let me just investigate that. This is the thing of the live demo, that's no problem. Altair, we're from Pollux, serve Mars, we're getting allowed HTTP, that's WMI that we're using. So scripts, our risk is not sufficient enough, so that's probably the thing. That's the thing with the risk engine, it's hard to protect what the risk he will take. We can inject some risk, but our policy is on high or above. So we might be a little too, we're not critical enough. Let me change it to medium or above. So that's the thing with the risk analyst. Of course, you need to basically guess a bit what kind of injection you need, which is not really a problem. We just, let's see if we can get it working if we change our risk level a bit, our threshold a bit lower. Our policies are synced, so let's try it again. No, that's the wrong command. There we go. Yes, that's better. So now we get an MFA request, and now I'm gonna block it and say, no, don't do this. This is not, it means it's an attacker, right? This is the point of view from the administrator, Altair, getting this, but he's not really doing anything. It's the attacker. Sorry for the confusion there. It's the risk engine doing his own thing, of course.
I think it's safe to say, because we are doing this in demo and we are testing this all the time, the risk engine doesn't really have an idea what we're doing at some point. In the normal production environment, this would be a high risk, of course, but it's because we already did this test that it's difficult for a risk engine to baseline what is normal behavior.
Yeah, it's also, you need at least a few weeks of running. We're only running it 2 days. We're resetting the environment. So, but it's fine. We see here that the risk was only medium, so we adjusted the policy, and now we get a blocked MFA on our attempt. If you inject this 2 times, if you inject it a bit more aggressively, that will be a high risk, and we're good to go on that environment. Now, last thing we want to do in our last minute that we have for this webinar is we want to do this command a few times. We basically want to block it a few times, right? So sorry for the screen in the back, but let me just do it once. Let me do it again. We will get an auto block. And look here what happens. our program has detected. Remember, second flow, we're looking at the blocked MFAs, and we're basically getting no action needed. Second block, no action needed. 3 blocks, right, in a certain time window. That's too much. Someone is trying to abuse this account. Someone is trying to do something with my admin Altair. So I'm isolating the host Pollux, which we suspected to be the one that actually is compromised. I can show you Pollux is disconnected, and I can also show in Cortex, if we go to the endpoint administration, I will do it in a new tab. You'll see that actually there we are, Pollux, and this is a sign of a host being isolated from the environment. So that's the actions we could take. So it's completely gone now. Pollux is off the network because we suspected that we have a attack there, and our meterpreter is completely gone. I think with that said, we can finish the demo and maybe go over to a few questions then.
Yeah, let me check. So if you have any questions, please put them in the question box so we can answer them. I already saw one question. One of those questions was, so okay, with the Kerber roasting, we see that we were that you could decrypt the file. How can we protect ourselves against something like that?
Basically, it's the password, of course. The password is easily to crack. You cannot protect something like Kerber roasting. Everybody can get a ticket, right? But it's important to notice that Cortex did an alert on it, so that's already something you have. So the protection mechanism that we built is effective. But in terms of making sure that you cannot crack the password, make the password complex, that's one thing. Also notice that this is an RC4 encrypted password, which can also be leveraged or be enhanced to AES-256. The problem with that is that some legacy applications in a Windows environment really needed to be RC4 for compatibility reasons. So it's not always easy to get that higher encryption standard in place. Then use a mechanism like this. You have to do it for legacy applications. It's fine. Just make sure that you can protect your critical assets and your critical accounts.
All right, I think that is clear. Another question is, so those service account rules in Silverfort, do we have to make those ourselves? So do we have to add sources and destination objects, or how is it built?
No. So if I quickly go back to the Silverfort dashboard, right here. So this is a table that is being populated automatically. So Silverfort looks at, we have that complete insight in the environment. Silverfort looks at behavior and sees that behavior of certain accounts is linked to a service account. You can help the system a bit and say, yeah, this is correct, this is not correct, but in the end, it's being populated automatically. It gives you an idea of what are the sources, what are the destinations automatically. And the only thing that you need to do is confirm here, say, yes, that's correct, that's the flow, that's the valid flow, activate the protection, and everything that is not in the valid flow, we're going to block it, we're going to log it. You can start with the log, not the block, so you can see in the logs if Silverfort would block anything that is normal and that you might have missed in the flow, you modify it, and then in the end, when you're happy with it, you click on a block. Environments have a lot of service accounts, and this is a very effective, easy way to change the to protect the service account flow. Sorry.
All right. I think it's safe to say that a lot of companies don't have that visibility in place about which account has access to what.
Yeah, indeed.
Okay. Another question is, why has the service account has a high risk? So at a certain point, the risk was critical. Why is that for the service account?
That was probably so the question is indeed, why is this a critical risk account? One of the reasons, so indeed it's a critical, we didn't do anything with it, so we didn't update the risk or anything, but one of the reasons is that Silverfort sees this as a service account, right? It knows that it's a service account because of the analysis. It knows that it's an admin because it has visibility on the Active Directory environment, so that's not good, right? It's seen that it's been used for brute forcing. That's us in our attack, and we also did an interactive logon with a service account. That's because we did a Kerber roasting. We asked for a Kerber roast ticket from a normal account. That altogether probably makes this a critical one. That's probably the reason. We also see some abnormal activity. but I think that this is definitely the reason why this is a critical risk. So also see here that the built-in mechanisms of Silverfort already made this critical. That's really the risk engine doing its job on seeing abnormal behavior.
Okay, so this is all Silverfort in this case.
Yeah, we didn't do anything with it in the API.
All right, great. I think those were the questions. And if you look at the time, we have 1 minute to spare. So perfect. So if there are no other questions, Floris, thanks for the demo. Good to see you again. Thank you for joining us. So if you have any questions about the Silverfort part, please contact me. And my email address is shown here. If you have any questions about the Cortex Palo Alto part, please contact my colleague Quinten. He will be happy to help. And I think you should be ready now to sell this, or at least to want to try Silverfort. So please contact us and make sure you're able to understand why this is so important to have that visibility inside your accounts. I cannot emphasize this enough. The last SolarWinds breach was critical. Why was that? Because the leverage of service accounts. This is the new thing that attackers are using. Make sure you have that visibility and that protection of it. So, okay, thank you guys for joining us today, and have a nice day. Enjoy the weather.
Yeah.
Bye-bye. Thank you.
Bye-bye.